Hello, my name is Cheyenne Hayes. My group consists of Brianna, Graciela, and Janetta. We will be discussing the lifespan changes in motor control and motor learning. I'd like to start by discussing what is motor control and motor learning. Motor control, according to the textbook, is the subdiscipline of human movement studies concerned with understanding the process that underlies the acquisition, performance, and retention of motor skills. Motor learning, according to the textbook, is the field of study concerned with understanding the changes in motor control that occur in response to practice, also known as skill acquisition. Motor control is more involved with neuroscience, where motor learning is more involved with cognitive science. Next, I would like to discuss the components of motor control and motor learning. The main components of the nervous system, the neuroscience behind the motor control and motor learning, are sensory receptors, motor units, and neurons and synapses. Sensory receptors, which have a lot to do with our senses, 4 out of the 5 senses are used: hearing, seeing, smelling, touching. These are all included with the central nervous system. The 2 main sensory information guides that control movement is our vision and proprioception. Proprioception is the information about the movement and orientation of our body and body parts in space. All sensory receptors share the function of converting physical energy into the body, or even outside the body, into nerve impulses. Motor units have been considered the source of neural input to the muscular system. One thing I found interesting from the text is that a general rule for motor units is the fewer muscle fibers there are, the more precise the control. The role of the neurons and synapses is that they allow the sensory receptors and motor units to work together and to have an effective two-way communication. This helps the human nervous system by giving it good foundation. Without the neurons and synapses, component skilled movement would pretty much be impossible. Next, I would like to talk about the main components that cognitive science show of motor control and learning, which are degrees of freedom, motor equivalence, serial order, perceptual motor integration, and skill acquisition, which all show how the nervous system is kind of like a computer. You input information, which goes into the central processing system, which results in the output of information.
Hi, my name is Graciela Perez, and I'm going to be talking about the subdisciplines. Okay, there are 2 major subdivisions that motor learning and motor control derive from. They are called the central nervous system and the peripheral nervous system. Okay, so the central nervous system basically consists of the brain and the spinal cord. By allowing them to oversee and combine all the information and movement of the body, it controls any type of emotion, thought, or movement, whether it's exercising or even the simplest thing like breathing or whatever. The brain controls the body. It is in charge of all the thoughts, emotions, hormones, creation of memories, and so on. The spinal cord is what holds our body in place, but not only that, it also carries information from the body to the brain. The peripheral nervous system is what is outside of the brain, basically like any nerve surrounding the brain and the spinal cord. For example, it really is just like the eyes, the ears, the face, like any nerves that connect all that, or any muscles surrounding the brain and spinal cord.
Hi, I'm Brianna. I'm going to be talking about the concepts of motor control and learning. Alright, so we are now going to talk about the basic concepts of motor control and learning. First of all, the nervous and skeletal systems work together to perform human movements. The nervous system can be split into two parts, the central nervous system and the peripheral nervous system. The central nervous system is made up of the brain and the brain stem, spinal cord. The peripheral nervous system is made up of the nerves. We can then break it down to three parts: sensation, response, and integration. These are how the body responds to certain stimuli. So in sensation, the afferent branch is involved, which is the peripheral nervous system sending information to the central nervous system. In the response part, which is how the body reacts to the stimuli, it involves the efferent branch, which is the central nervous system sending information to the peripheral nervous system. And in integration, the information from the stimuli is received and processed, and that is how both parts of the nervous system work together. Now, moving on to the concepts of motor learning, it's making a permanent change in the neurological functions which happen in the brain. It's split into three different stages: cognitive, associative, and autonomous. In the cognitive stage, the learner is trying to develop an overall understanding of a skill. For example, in the process of learning how to walk, a child will be looking to see how others do it, and it's more of a trial and error stage. In the second stage, which is associative, the learner begins to demonstrate more refined movements through this practice. And then in this stage, continuing with the walking, it's more so of the child being clumsy. They've got the overall understanding of how to walk and how to do it, but it's at the time period of which they're not exactly perfected it yet. And then in the autonomous stage, the skill becomes more automatic. So in this stage of walking, the learner can perform the skill in any environment with very little cognitive involvement compared to the first stage. So moving on to the concepts of motor control, it deals with issues such as information processing, attention and interferences, the mechanism of muscular coordination, and sensory contribution to motor performance, also as well as production of movements through the neuromuscular system. Motor control is split into two different parts: fine motor skills and gross motor skills. Fine motor skills are the smaller movements, which could be grabbing a spoon. As my example, in our everyday life, we use fine motor skills in texting on our phones. Moving on to gross motor skills, these are larger movements. We see this in walking every day, whether it be to class on campus or to our car.
Hi, I'm Janetta Preston. I'm going to be doing the change over the course of life. I'm going to start with age. Age is something that plays a factor because it is very important in the role of life. Well, motor skills are very important and during lifespan, and as we get older, we may have to learn or relearn new skills or even the skills that we've lost. As we grow older, we experience psychological changes that may cause glitches in our brain functions that we've taken for granted. Those small things that we took for granted that we used every day and didn't really just think about can be taken. This goes back on lifestyle, habits, and daily activities have a huge impact. Also, when it comes to age, like you're not doing, your lifestyle is completely different from when you were 20 now that you're like 60. So you start picking up new habits or even stop doing those daily activities that you were doing due to you getting older. It goes back to that saying, use it or lose it. If you don't use those skills, you will eventually end up losing those skills. But that's not always the case. Sometimes the skills that you do use, you can lose those also. Another thing is body capability. Different things can affect your body, causing it not being able to learn or perform those tasks anymore. Being that it'd be an injury, maybe it's an athletic injury. We're looking at something down the line for like an older person. Maybe they had to get hip replacement. Different things like that can cause them not to be able to perform or even learn a task like they did when they were younger, now that we're older. Some other things that may play a factor in that is illness and disease. The last thing that I have when it comes to the changes over a course of life is motivation. A person that's 60 now may not have that same motivation to get this skill back. Well, let's not say 60. That's probably even a little bit older than 60, may not have that same motivation to get back up and running as if they were 20. A person has to be willing and motivated to learn. They have to be open to that idea of getting that skill back. We can't just force it on them. And it also goes back to those 3 stages of motor learning too: cognitive, associative, and an autonomous stage. That can get very frustrating, being stuck in that second phase, the associative stage. It gets frustrating sometimes getting stuck in there because you know what to do, you know it's there, but you're having to keep going over that same skill and it's not automatic yet, and that can be frustrating, and you can even lose motivation during that phase. The last thing I have to talk about is the connection of all this. Motor learning and control contributes to the foundation of the new learning, a learning of new and old skills. When looking at the other subdisciplines like biomechanics, which looks at movement and living body, how the muscles, bones, tendons, and ligaments work together to produce movement. When looking at sports psychology, which is the performance and looking at the exercise effects, psychological and physical factors, looking at functional anatomy, and even exercise physiology, which is the response to the ability to adapt to physical activity. All these connect together in the kinesiology family, in studying the mechanics of the body movements, which can aid in promoting health and reducing diseases.